Hello everyone, welcome to the BYJU'S Exam Prep, the most comprehensive app for all competitive exams. Let me know that sound quality, picture quality, everything is fine. Now that is the session for what? BARC 2023. It is a Parmanu series and I am going to take what? EDC, that is electronic devices and circuit. This is the daily practice paper. Okay, are you ready guys? Everyone please give me the comments. Yes, Ravi Teja, how are you? Very good morning. So everyone please join the session, like the session and share the link of this session. Okay. And we will continue at this time, that is what 11 a.m. because we are going to start what one important series for GATE 2024 in evening, that is at 9 p.m. Okay. Then guys, everyone please, are you ready to solve some important numericals from electronic devices and circuit? And this year in GATE 2023, right? Already it is over. The nature of question from semiconductor physics, from BJT, from operational amplifier and so on, that is what easy to moderate we can say. And in BARC we can expect similar type of questions. So we will solve some important numericals from semiconductor physics, BJT, Diode, MOSFET, right? Are you ready? Okay guys. Then this is a Parmanu series and this is my introduction. Myself Sanjay Rathi. I am having around 22 years of teaching experience in the field of competitive exams like EDC, GATE and PSUs. And these are my ranks in EDC. AIR 16 in EDC 2005, AIR 21 in EDC, that is Engineering Services Exam conducted by UPSC. And I worked as Deputy Director in Ministry of Power. Now I am here to share my experience with you. Okay guys, so before starting the session I want to give you some important information. For GATE 2024 we are going to start one fundamental series, that is for electronics, electrical, instrumentation and computer science branch. Now simplify your preparation for GATE with BYJU'S Exam Prep. Already it is started from 1st March. First session on that at 9 p.m. Please join that. Okay. And this is a free workshop by Richa Gupta madam, highly experienced. Okay. Please join that. Register yourself for this on 2nd March at 7:30 p.m. That is how to GATE 2024 with college or what job. Okay. तो ज्वाइन कीजिए अगर आप गेट 2024 के लिए प्रिपरेशन कर रहे हैं, रजिस्टर कीजिए ऑन आवर ऑफिशियल वेबसाइट दैट इज BYJU'S Exam Prep. अब आते जरा, दैट इज द फर्स्ट क्वेश्चन. एवरीवन ट्राई टू गिव मी द आंसर, ट्राई टू गिव मी द आंसर फॉर दिस पर्टिकुलर क्वेश्चन. राइट, ऑलरेडी डेट अनाउंस्ड फॉर BARC, आई थिंक इट इज 8th and 9th April. Yes, Ravi Teja. Initially it was 1st and 2nd, now it is what 8th and 9th April. Please fill the form. I think already you have filled the form for that and start your preparation. It is a quick revision is required here, right? And there is a difference between the pattern of GATE exam and pattern of what? BARC exam. Remember that. So tell me, a bar of gallium arsenide is doped with the silicon such that silicon atoms occupy gallium and arsenic side in the gallium arsenide. Which one of the following statement is true? Which of the following statement is true? Okay. Which one is the correct one? Tell me. भाई जितने भी हैं आप जो भी अटेंड करें, प्लीज गिव मी द आंसर फॉर दिस क्वेश्चन. दैट इज this is a silicon bar. Now this is a gallium arsenide. Gallium is the 3rd group and arsenide from the 5th group. Okay. And silicon in outermost orbit we have the 4 electrons. Okay. So towards what? अब आप देखिए जरा, silicon atom act as p-type dopant. It means what? In arsenic side it has one extra electron, that's why it will accept one electron. That is what? Yes, I am correct. Yes, Dip. So आपका क्या होगा, दैट इज अगर वी आर यूजिंग द सिलिकॉन एटम एक्ट एज व्हाट, you are giving the answer B. Silicon atom act as N type dopant in arsenic side and P type dopant in gallium. Okay, tell me what is the P type dopant means? Acceptor. P type dopant means acceptor. It will accept one electron. N type means donor. It will donate one electron. In gallium side, it is a trivalent, means it is a group third, and that's why the silicon will donate here. Silicon has one extra and that's why it will donate here. And in case of arsenic, it will accept one electron. And when it accepts, it means what? It is a P type. So which answer is correct now, Deep? Which answer is correct? Silicon atom act as P type in arsenic side and N type in what? Gallium side, because it will donate one electron, right? And now everyone please remember that okay, they will ask this type of questions on what? Donor and acceptor impurity. When we are giving Na, when we are giving Nd, what about the built-in potential? Similar type of question in GATE exam, it is converted into acceptor ions. It will accept one electron. And these are the holes. These are the donor ions, they will donate one electron and so on. A number of questions on this. Okay, next question. Next, try to give me the answer for the next one. A silicon bar is doped with donor impurity Nd, that is the 2.25 into 10 raised to power 15. Some students say that this is a very easy question. So my dear friend, this similar type of question in this year in GATE exam. But what is the formula based? To quick revision, in limited time you have to solve this. There is a difference between the pattern. Try to solve within 30 seconds or within 1 minute. Okay, what is the answer? Silicon bar is doped with donor impurities. Nd is equal to 2.25 into 10 raised to power 15 atoms per centimeter cube. Given the intrinsic carrier concentration of silicon at 300 degree Kelvin is Ni 1.5 into 10 raised to power 10. Assuming the complete impurity ionization, the equilibrium electron and hole concentration are. Remember one thing, Ni, when we are comparing with the Ni, that is 1.5 into 10 raised to power 10 per centimeter cube. This Nd is very high, 2.25 into 10 raised to power 15. This is very greater than Ni. In that case, we can say N is nearly equal to what? Nd. That is 2.25 into 10 raised to power 15. No need to use the exact formula. Then directly you can use the mass action law. So what is the concentration of hole? That is given by Ni square by what? Nd. Ni square by Nd. So what is the Ni square? 1.5 into 10 raised to power 10. That is the square upon what? Nd. 2.25 into 10 raised to power 15. And you will get the answer 10 to the power 5 here. N naught is 2.25 into 10 raised to power 15 and P naught is what? 1 into 10 raised to power 5. Okay, D is the answer. Bilkul sahi hai. That is the correct one. Now they will ask, if suppose I am increasing the doping concentration Nd, then the concentration of hole will reduce. Concentration of hole, that is the concentration of minority carrier concentration. Minority carrier concentration will reduce. Okay, and that is the case. Now next one. Next question. At 300 degree Kelvin, the whole mobility of the semiconductor. Everyone give me the answer for this question. Yes, please. What is the answer for this one? क्या आया भाई? At T 300 degree Kelvin, the whole mobility of a semiconductor is this one, and KT by Q, the whole diffusion constant. Very simple. First of all, remember the unit. New students, everyone, remember the unit. Okay, what is the unit of that? And then try to solve. Diffusion coefficient. And here the mobility is given. Means what is the relation? Einstein relation. What is the Einstein relation? dP by mu p is equal to what? dN by mu n is equal to Vt. Okay, Vt means Kt by Q. K is the Boltzmann constant, T is the temperature, Q is the charge. So this is T by 11,600, right? And it is in volt. And temperature in degree Kelvin. Remember that temperature, it is in degree Kelvin. So 300 degree Kelvin it is given. The whole mobility of a semiconductor, it is given centimeter square per volt second. And the whole diffusion constant. From this you can find the dP is equal to what? Mu p into Vt. Mu p into what? Vt. This is given as 500. Always remember the unit of that. This is the unit is centimeter square per second. That they will ask the unit or dimensional formula into what? 26. Now you will get, this is a very simple one, 13. 13, that is the C is the answer. You have any idea about the dimensional formula of the mobility, everyone? They will ask what is the dimensional formula for the mobility also. So you have to find the dimensional formula for mobility, but remember the unit is what? Centimeter square per volt second. And this is the volt. This is in volt. Okay, next question. Next one. The drift current in semiconductor depends upon. What is the drift current density or drift current? I is equal to AJ. Right? A is the area of cross section, J is the current density. And the J is given by sigma E, right? J is given by sigma E. So semiconductor means sigma. What is the sigma? NQ mu n plus what? PQ mu P, right? So it depends upon what? When we are saying that what is the complete formula for I, so we can say A, Q is a constant, and then N mu n plus P mu P into E. So it depends upon the electric field as well as it depends upon the concentration. Both electric field and carrier concentration. So that is the carrier concentration. So this is the C. Right? Drift current. Then what about the diffusion current? The number of questions on diffusion current. Right? So in a diffusion current density, this is about the drift current. In a diffusion current, for holes, the current density is given by I by A, and that is minus Q dP by dx. It does not depend upon the electric field, it does not depend upon the concentration, it depends upon the concentration gradient, right? dP by dx. Similarly, Jn is equal to I by A, that is Q dn by dx. Q dn by dx. The dP by dx or dn by dx is what? Concentration gradient. That phenomena is called diffusion, migration of charged particle from higher concentration to lower concentration. Okay, so this is called diffusion phenomena, and it is independent of electric field, it is independent of the concentration, it depends upon what? This dP. Some student will say that, sir, it is independent of mobility, but remember that dP. What is the dP? Mu p into Vt. What is the dn? Mu n into Vt. Mu n into what? Vt. And Vt depends upon the temperature. Remember that. Okay. So we have to use the Einstein equation also. Okay. There are number of questions on diffusion current, right? Because in case of diode, in case of BJT, that is a very important phenomena, diffusion phenomena. When we are giving the light, what will be the phenomena? You have to revise. Please revise all these things quickly. Suppose this is a bar, right? At this end, we are giving the light. Then what will happen? New hole electron pair will generate here. Therefore, the concentration of electron as well as concentration of hole will increase in this region. When the concentration of hole and electron will increase, then there will be the concentration gradient. There will be the concentration gradient. Like this is the initial hole concentration. Okay. Now this is called excess hole concentration. This is the excess hole concentration because of this lighting effect. Now what will happen? Diffusion from higher concentration to lower concentration. From higher concentration to lower concentration. This is the X, and let this is the concentration of hole. So this is called concentration under equilibrium. Now this is the excess hole concentration. This is represented by P-0, and this is the initial concentration. So what is the total hole concentration exactly at X is equal to 0? This is given by excess hole concentration plus initial hole concentration. This is the N-type bar. N-type bar. So N is equal to Nd, and therefore Pn naught initial concentration of hole is Ni square by Nd. So when we are giving the light, a new hole electron pair will generate, and then it will follow which formula? Exponentially decreasing formula. Exponentially decreasing formula. Right? Why session at this time? Venkat Raman, we are going to start with one important series at 9 p.m. Now all the session for BARC exam will be at the same time, that is 11 a.m. Okay. In evening, please ask your friend to join the session and share the link of this session, right? So that they will not miss this session. This is a very important one. At 9 p.m. we are going to start what fundamental series for GATE 2024. You can also enjoy that, but we will give you the very basic idea about what every subject. For example, we are going to start with what network, okay, for 2024 GATE exam, okay. Because some students are very weak in what concepts and fundamental, and that's why it is not possible to simply qualify the GATE exam. That is the theme of that series, okay. So now this is the case. So what is the equation? Px. This is the function of x, and that is the given by Pn naught. It will remain constant, but this term will decrease. And here Lp is called diffusion length. Diffusion length. And Lp is given by root over dp tau p. There may be the question on this formula dp tau p. Tau p is called mean lifetime. That is the average time between generation and recombination. Mean lifetime. And that is the formula. So this is a very important equation. Remember that directly there will be the question on this formula. Okay. This is what depends upon the distance. This depends upon the distance from this point to this point. When the hole diffuse from higher concentration to what? Lower concentration. Okay. Then now next one. Next question. Okay, tell me. There may be the chance of what? Silly mistake. To give me the answer, quickly give me the answer. Read question as fast as possible. Then try to give me the answer. Because we have to solve number of questions within limited time. So what? There may be the chance. Tell me. The ratio of the mobility to the diffusion coefficient in a semiconductor has, what is the unit? What is the unit of that? What is the unit? Okay. Then volt negative, centimeter per volt, volt per centimeter, D volt. Right. Hariom, Rohila is given. Your A, B, C, D, which option is correct? A, B, C, D. हाँ रोहिला हरिओम, your answer is correct. और देखिए this time this is what is the Einstein equation? Normally we have idea about that dp by mu p, right? This is the volt, this is the Vt, volt. So dp by mu p is volt, but it is asked what? Mobility upon diffusion coefficient, 1 by Vt. Then it will become what? Volt inverse A. Remember the unit of this is centimeter square per second. Unit of mu p is what? Centimeter square per volt second. And that's why it is volt. but inverse of this is what? Volt inverse. So A is the correct answer for this question. Yes, A is the correct answer for this one. Okay. So similarly, you have to revise what all the formula for what Fermi level. For example, this time very easy question on Fermi level, but in EDC there is some debate. No problem, but get the idea about what is the EC, EV, intrinsic Fermi level, EC, EFI. Already in number of sessions you can attend also my marathon session. Here you will get the formula. EFI for P type. This is the EFP. Right, what is this gap? Right, what is this gap? Get the idea about that. Capital लिख लेते हैं, or we can say simply P. That is the concentration of hole. So get the idea about this gap. This is the gap between EFP and EV. This is the valence band. This is the conduction band. Directly formula based question होगा तो ये देखिए याद है KT log of Na by Ni. Right, EFI, what is the NV, what is the ND, what is the effect of the temperature on the NV and ND. Okay, please revise that. Please revise all that formula. Okay, next one. Which of the following is true? Which of the following is true? तो Fermi level पे questions आएंगे straightforward. Already we have solved number of questions on that. So new student, you can join that Maha Marathon session on EDC. So it is a daily practice problems है. तो ये चलिए बताइए जरा क्या होगा. This is a daily practice paper. Give me the response. Which of the following is true? Silicon wafer heavily doped with boron is a P positive substrate. Silicon wafer lightly doped with boron is a P positive substrate. Silicon wafer heavily doped with the arsenic is a P positive substrate. Silicon wafer lightly doped with arsenic is a P positive substrate. So what about the boron? Boron is a trivalent. Means it is an acceptor. It will accept one electron and create the hole. And that's why this is converted into, when we are giving the boron, it is converted into P type. And it will create holes. And when we are giving very high doping, then this is called P positive type. P positive means very, very high doping. P positive means what? Very, very high doping. And that's why the answer A is the correct. If arsenic is given, then it will accept what? It will donate one electron and positive ions. Then it is called N positive type. If it is heavily doped, then it is called N positive type. This is the electrons. So this is called N positive type. Okay. So A is the correct one. Then next one. In a P positive N junction diode under reverse bias, the magnitude of the electric field is maximum at. This topic is again very important in PN junction. This topic is very, very important in PN junction. Tell me where we are going to get the maximum electric field. This is the junction, right? And when the P positive N means doping is very high, so depletion width. This is on the depletion width on the P side, and that is the depletion width on the N side. Or in the depletion width, we are having what? Immobile charge carriers. Here we are having the positive. This is the, we are saying X is equal to 0. This is the WN, depletion width in N side. This is the depletion width on the P side. Here it is a negative charge. If it is uniformly doped, always remember, if it is given like this, it is a square or rectangular shape, then it is called uniformly doped. This is the uniformly doped. Remember that word is used, uniformly doped. Square shape. Uniformly doped means what? Square shape or rectangular shape. It is a zero level. So it is a negative charge here. This is the negative charge and it is a positive charge. When we are using the Poisson's equations and when we are integrating, then we are getting That is because the formula is minus rho by epsilon s, where rho is the volume charge density. Volume charge density. Right? So when we are integrating, so what is the integration of the square? That is the triangular. And that's why we are getting this type of shape. And this is called uniform doping. So some students are confused. Sir, it is a step graded. How you are saying that it is a uniform doping? No, it is no doubt it is a step graded. No doubt it is a step graded. But try to understand this concept. Some students are highly confused with this. Okay. Now, this side, it is a P type. P type means what? We are giving the Na doping. What about the NaP concentration? I am just saying that the concentration of P is very, very high here. And this is the N type. So N is equal to Nd. But what is the P is equal to? According to mass action law, Ni square by Nd. So this is called Pn naught. The concentration will suddenly fall. And that is called step graded. That is called step graded. Pn naught, and this is the concentration is very, very high for P type. This is P is equal to Na. So that is the step graded. Okay, no problem. But in the P side, the doping is what? Uniform. From this point to this point, the doping is constant, Na. And that's why seems like this. Uniform doping. That is the meaning of uniform doping. Okay. Similarly, this side N, it is again uniform doping, uniformly doped. It is also uniformly doped. Overall junction is what? Step graded junction. Overall junction is what? Step graded junction. Here P is uniform, here N is what? Uniform, and so on. That is the case, step grading. Now, in that case, normally they will ask question on that. So this is the case. Now, when we are integrating, because this area is neutral, this area is neutral, this area is also neutral, and that's why in this region the electric field is 0. But when we are integrating, because it starts with the negative, and we are getting this type of shape, right? And exactly at the junction we are getting the maximum electric field, the P positive N junction. That is the right answer. P positive N junction is the right answer. Okay, but they will give you the shape and they will ask what about the doping and so on. So please revise this one, because this topic is very, very important on PN junction. And when the junction is reverse bias, then okay. तो चलिए अब आते हैं नेक्स्ट क्वेश्चन पर. Next one. Okay. A uniformly doped abrupt PN junction, the doping level of the N side is 4 times the doping level of P side. It may possible. This time on N side the doping is very high. N side the doping is very high means what? This is the PN positive. We can say PN positive junction. The doping level of the N side is 4 times the doping level of the P side. The ratio of the depletion layer width of the N side versus the P side. Quickly give me the answer. Right. What is asked here? The doping level of the P side, the ratio of the depletion layer width of the N side versus the P side. Okay. Which answers are wrong? Oh, there are 2 options. Same to same. This is 0.5. 0.5. So remember, if it is doping is given, here we are giving Na type, here we are giving Nd type. Depletion width here it is given by Wp. Depletion width here it is given by Wn. Na into Wp, this is the formula. Nd into Wn. Na into Wp is equal to Nd into Wn. What is the Wp by Wn? Wp by Wn. This is ours. The ratio of the depletion layer N side versus P side. So we have to reverse that. Wn by Wp. Wn by Wp, that is asked. Na by Nd. And this is the Na divided by 4 times of Na, because it is the 4 times, and that's why it is become 0.25. That's why it will become 0.25 A. Easy. अभी पेपर देखो भाई, ऐसा ही आया हुआ है क्वेश्चन, ऐसा मत सोचिएगा कि यार इतना इजी. तो क्विकली इसमें भी सिली मिस्टेक्स करके आए हैं बच्चे. ट्राई टू अवॉइड द सिली मिस्टेक्स. ओके, तो some student will give, suppose here answer is what, one answer is maybe, let maybe 4. So some student will give the answer 4 suddenly, because you have to read the question carefully. The ratio of the depletion layer width of N side versus the P side means Wn by Wp is required. Read question carefully, right? Read question carefully. Okay. Now, quickly give me the answer. In an abrupt PN junction, the doping concentration is this one. The PN junction is reverse bias and the N side depletion width is 3 micron. Depletion width on the P side is. Depletion width on the P side is. Again very easy. Na is given, Nd is given, PN junction, N side depletion width is given 3, depletion width on the P side. So already Wp by Wn inversely proportional. Now remember, directly you can use this formula. It is inversely proportional to the concentration. That's why this is the Nd by Na. It is inversely proportional to concentration. That's why Nd upon Na. So Nd is given as 1 into 10 raised to power 16. Na is given as 16. Okay. Now Nd, what is the depletion? PN junction reverse bias, the N side depletion width is 3 micrometer. Nearly, which answer is correct? B. Yes, you can check your calculation. Okay. So that is the case. Remember that formula and you can write. If the doping is high, that is, suppose doping is high, then depletion width will be low. So it is directly divided by that ratio, that is the 3 divided by 9. You can directly find the value, just like aptitude, within seconds. Within seconds we can find the value. Yes, this is the correct one. Now, for a silicon NPN transistor, the base to emitter voltage is 0.7 volt and collector to base voltage is 0.2 volt. Then the transistor is operating in. NPN transistor. NPN emitter junction, collector junction. This is VBE, means this is the VBE. This is NPN. This is given as 0.7 volt. Base terminal, emitter terminal, 0.7 volt. And the collector to base voltage. Where is the collector? This is the collector. To base voltage, VCB, 0.2 volt. Base collector BV, when we are writing the VCB means VC minus VB. VC minus VB is 0.2 volt, means definitely the VC is greater than what VB. When the collector terminal is greater than the base terminal, means that junction is reverse bias because it is N type. Or here the base is greater than the emitter, and that's why this junction is what, forward bias. So this is the forward bias. So which is in which mode? In which mode? Tell me. Very simple question. अभी तक जवाब ही नहीं आया आपका. If a silicon PN junction base to emitter voltage 0.7 and the collector to base voltage is 0.2, then the transistor is operating in. Right. It is in active mode, normal active mode. Remember one thing, if that is given, simply VCB is 0 is given again. VCB is short circuited simply. Okay, always it is, remember that VCB is, if it is short circuited, means collector junction is reverse bias. And this junction is forward bias, and then the transistor is in what? Active region. So simply sometimes to avoid the saturation, we are simply short circuiting the base and collector. Base and collector are short circuited. This is the collector, this is the base, and here we are getting the VBE. So collector is shorted to base means it is the collector junction is the reverse bias, means transistor will never goes into what? Saturation. To simply the simple fundamental to avoid the saturation is what? Short circuit the collector and base terminal. Or sometimes we are connecting Zener diode here. Sometimes we are connecting the Zener diode here. This is the Zener diode. This is the VC. This is the VB. And now this is the VB. Now try to understand. When that will be the case, always remember, first of all, because of this battery, that Zener diode will break down. Once the Zener diode will break down, then it will allow the current IB. IB will flow like this through the Zener diode. Now it is the breakdown. And this is the collector current IC. So what is the current here? IC plus IB. And if it is sufficient voltage, then the transistor will be in what? Active region. It will never goes into saturation. How? You can calculate the VCB. What is the difference between V and B? VCB is nothing but VC minus VB. It is nothing but what? VZ. For example, VZ is 3 volt. We can maintain the 3 volt. Means collector junction is reverse biased by what? 3 volt. It is reverse biased by 3 volt. So in this ये है case. तो अभी Zener diode लगा है तो they will ask what is the purpose of the Zener diode, right? We are using the Zener diode to maintain what? VCB, and that collector junction is what? In a reverse bias condition. Reverse bias. Okay. Transistor is maintained in active region. Normally we are using this type of concept in what? Non-saturated logic, non-saturated binary, we can say. So this is the concept, non-saturated. Non-saturated means in this case BJT will never goes into what? Saturation. That's why it is called non-saturated logic. Non-saturated. Okay. So question आ सकता है. But this voltage should be sufficient. For example, if it is a breakdown voltage for this Zener diode is 3 volt, then it should be 10 volt or 20 volt, 15 volt and so on. That is sufficient. It will break down the Zener diode. There will be the current in this direction. When there is IB, there will be the IC, and you can solve like this. Okay. And what is the simple remedy? Simple, connect what? One from collector to base. Third solution, when we are connecting a resistor here, again no problem. This is called collector base biasing. Resistor here. Again, this is the IC, this is the IC plus IB, and this is what? IB. Again, it is not in saturation. Not in saturation because what is the VCB? VCB is what? VC minus VB, that is equal to what? IB into RB. This is the IB into RB, and that is greater than 0. Means again the collector junction is reverse biased. Yeah, this is one type of technique. This is called collector base biasing. Collector base biasing. Okay. Next one. The action of JFET in its equivalent circuit can best be represented as, what is the JFET? Junction field effect transistor. It is not in syllabus of GATE, but in BARC they may ask question, what is the JFET or MOSFET? From the small signal model, this is the gate terminal, this is the source for common source. In a small signal model, this is the called drain resistance GM-VGS, and this is a voltage controlled current. GM-VGS, voltage controlled current source. Yes, Rahul Ranjan, your answer is correct. Voltage controlled current source. D is the correct one. Okay. तो देखो मॉडल देखो ना, मॉडल में क्या दिया हुआ है? JFET. What is the equivalent model? That output current is controlled by what? Voltage. No doubt it is a voltage control device. Yes, this is a voltage control device. This is the VGS. But what is controlled here? Current is controlled by the voltage, and that's why it is called voltage controlled current. In equivalent circuit can be best represented by, that is the equivalent circuit. Deep, I think that is clear to you. Okay, next one. MOS capacitor made using p-type substrate is in the accumulation mode. Everyone give me the answer. MOS, this is a p-type substrate. N positive. We are applying the VGS here. P-type substrate means the body is P-type. This is the N-channel MOSFET. This is the drain. This is the source. Metal, SiO2 layer. Now, MOS capacitor made using the P-type substrate is in the accumulation mode. The dominant charge in the channel is represented by. क्या होगा भाई राहुल? Everyone. MOS, that there may be the question on what MOS capacitor. MOS capacitor is important topic. MOSFET is important topic. Everyone please revise that. B, electron. Dominant charge in the channel is due to the presence of. This is in which mode? Accumulation mode. It is a P-type substrate. Okay, body is the P-type. Accumulation means when there is an accumulation of what? Majority carrier. So which are the majority carrier? Holes are the majority carrier. Accumulation means in N channel when we are giving the negative charge. When we are giving the negative charge, it will attract holes here. And this region is called what? Channel region. This is the channel actually. When hole is accumulated, then it is called what? Accumulation mode. Right? Majority holes. So majority is what? Holes is connected here. So what is the answer? Holes. A. Now try to understand. All the forms are important. So first of all, remember this is called accumulation. Holes is accumulated here. Right. This is called accumulation. VGS is highly negative, less than 0. Now, they will represent this diagram. This is the SiO2 layer. This is the 0 level. At this point, we are giving the negative voltage, and that's why this negative voltage is represented by this one, negative voltage. On the gate side, this is called gate side, this is silicon side, and this is the SiO2 layer. SiO2 layer. So here it is the negative charge. Equivalent to that, here we are getting the positive charge. That is the holes. So this is called what? Accumulation mode. In depletion mode, what will happen? Depletion mode means when we are making it positive. Positive. But less than what? Threshold voltage. Less than or equal to what? Threshold voltage. It will repel the holes. It will repel the holes, and that's why the depletion layer will increase. It will repel the holes. That's why the depletion layer will increase, and that is called what? In depletion mode. The depletion layer will increase and overall capacitance will reduce. In that case, the capacitance is, overall capacitance is what? Oxide capacitance. Overall capacitance is oxide capacitance epsilon naught upon TOX into A. But in that case, the depletion capacitance, because of this depletion layer will increase, capacitance will decrease. Capacitance will decrease. Now in third case, when we are giving voltage more than VT, then there will be the inversion. Then there will be the inversion. N positive, when it will attract electron. VGS greater than VT, now it will attract what? Electron. Or in that case, depletion layer will reach to its maximum. Already it reached to what? Its maximum. Depletion layer, XTT, this is called. This is the maximum depletion layer. After that, it will attract what? Electron, and that is called what? Inversion. That is called what? Inversion. So please revise this. Now, the drain current of MOSFET in saturation is given by ID is equal to K VGS minus VT the square, where K is a constant. The magnitude of transconductance GM is. What is the magnitude of the transconductance GM? Everyone tell me. What is the magnitude of transconductance GM? Then remember, GM is given by dID by dVGS. dID by what? dVGS. GM, right, with respect to what? VGS. So if the ID is given, differentiate it. If ID is given, now simply you can differentiate it. When you are differentiating it with respect to VGS, it will become 2K times of VGS minus what? VT. That is called transconductance GM. B is the correct one. Yes. So fast, quickly you have to give the answer. Quickly, as quick as possible. Okay. तो ये है issue. Right. 1 minute. (2K VGS minus VT). Now next one, the drain of N-channel MOSFET is sorted to gate. Right, next one. The drain of N-channel MOSFET is sorted to the gate so that VGS is equal to VDS. The threshold voltage of the MOSFET is 1 volt. If the drain current is 1 milliampere for VGS is equal to 2 volt, then for VGS is equal to 3 volt. What is the idea? Tell me. Now try to understand. ये ना simple concept है, just like BJT. Once the drain is sorted to what gate? Drain is sorted to the gate. It means it is in saturation region. This is the VDS, this is the VGS. When the VDS is equal to what? VGS, means VDS is greater than what? VGS minus VT. And that's why it is in saturation region. Saturation region, not in triode region. This is called RD and this is called VDD. VDD should be sufficient so that it will maintain the VGS more than threshold voltage. More than the threshold voltage. Okay, that will be in what? Saturation. Quickly you have to give the answer. The threshold voltage is given, the drain current is given, then drain current. Simply in that case, in a saturation, ID is equal to K times, you can take constant, VGS minus VT the whole square. So what is this? Is like this is the ID2. This is 2. So what is the ID1? K times VGS1 minus VT the whole square. Divide these two equations. So ID2 by ID1. K cancel and directly you can write this formula. Now always you can directly write this formula. In BARC exam, quickly. VGS1 minus VT the whole square. In first case, in second case, what is the voltage? 3. Threshold voltage is 1. 3 minus 1 the whole square. In first case, what is the VGS? VGS is 2 volt. Minus 1 the whole square. Then ID2 divided by ID1. In first case, what is the ID1? 1 milliampere. 1. So what is the ID2? 2 square, that is the 4 ampere. 4 milliampere. Okay, 4. So Rahul, yes, it is easy to solve the question, but directly no need to write this formula because it is not proportional to VGS. It is proportional to what? VGS minus VT the whole square. Directly you can write it is proportional to VGS minus VT the whole square. And that's why directly you can write ID2 upon ID1 is equal to VGS minus VT upon VGS minus VT 2, 1 the whole square. Finished. That is the answer. within one line, within 20 to 30 seconds we have to solve this type of questions. वहां verify मत करना, verify नहीं करना है, quickly you have to give the response. बहुत सारे क्वेश्चन सॉल्व करने रहेंगे आपको, देख लीजिए पूरा पैटर्न आप लोगों को हम लोगों ने पूरा सेशन में बताया, 100 क्वेश्चन, ड्यूरेशन, ईच एंड एवरीथिंग. नाउ द इफेक्टिव चैनल लेंथ ऑफ अ MOSFET इन सैचुरेशन डिक्रीजेस विद इंक्रीज इन effective channel length of the MOSFET in saturation decreases. Effective channel length of the MOSFET in saturation decreases with increase in. Tell me. Okay. In a saturation there is a pinch off. This is called pinch off of the channel. This is N positive, this is N positive, and already we have applied the voltage. Normally it is connected to ground and source is sorted with the body terminal. This is very important because this junction should be reverse bias. This junction should be reverse bias. This is called PN positive junction. This is called PN positive junction. This is the source body junction. This is the drain body junction. Both should be reverse bias. Exactly at the boundary of the saturation and triode region, VDS is nothing but VDS set. That is given by VGS minus VT. VGS minus VT. Yes, Piyush Rajput, scientist, you are giving the answer drain voltage. That is correct one. Exactly at saturation and the triode, at the boundary of the saturation and triode, what will happen? The VDS is exactly equal to VGS minus VT. So under theoretical condition, when we are giving the VDS greater than VGS minus VT, there will be the no change. But practically what will happen? This pinch off point will move away from the drain towards what? Source. So when it move away from the drain towards the source, then what will happen? That this is the channel area. Now this is the pinch off point. Okay, that is the drain area. This is the source. Again, when we are increasing the voltage, this will increase like this. The pinch off point will move away from the drain towards the source. Right now, this is the point. This is the point. This is the channel length L. In first case, when this is the pinch off point, this is the VDS is equal to VDS set. But in second case, this channel length will reduce and the pinch off point will move away. That is the del L, and the channel length will become L minus del L. There is a reduction in effective channel length. In this case, here the voltage is VD set. But when we are applying the voltage VDS greater than VGS minus VT, then what will happen? This will become extra voltage. VD set plus what? Del VDS. This is the extra voltage. Because VD set is VGS minus VT. Because of that extra voltage, depletion layer increases. This is the depletion layer. Actually, this is the depletion layer. And the extra voltage will come across this depletion layer. Effective channel length will reduce. And that's why the current will increase. And that is called which effect? Give me the name of the effect, everyone. Your answer is correct. That is called drain voltage. That is what? Drain voltage, VDS. So what is the effect? What is the name of that effect? Tell me. Okay. Now, because of this, there is a change in the characteristics. There is the change in the output characteristics. And that is called the boundary of the triode and saturation region. We are assuming that it is a constant, but it is somewhat elevated. that is elevated for different values of VGS. When we are increasing the VDS, this is somewhat elevated, and that effect is called channel length modulation or early effect. This is called channel length modulation or early effect. That is given by JM early. Okay. Somewhat elevated curve. IDS versus VDS. That is the output characteristics. Okay. Next one. Okay, tell me what is the answer. This is on switching. This is on switching from forward bias to reverse bias, from reverse bias to forward bias. Now tell me what is the answer. In the circuit shown below, the switch was connected to the position 1. This is the position 1, that is the position 2. It is changed to position 2. The switch will move from position 1 to 2. Assume that the diode has a 0 voltage drop. And the storage time, this keyword is used here, storage time. For 0 to t less than ts, VR is given by all in volt. So when the diode is, when we are making the diode, let that this is the diode, everyone give me the answer. This is called forward bias. And from forward bias to when it moves, reverse bias. Forward to reverse bias. Then it will, ideally the time will be what, 0. From forward bias suddenly it will become reverse bias, but practically it will take time, and that time is called what, reverse recovery time. Forward to reverse bias, forward bias to reverse bias, that time is called reverse recovery time, TRR. TRR has two components, one is called storage time, another one is called transition time. One is called storage time, another one is called what, transition time. Okay, now what will happen, everyone give me the answer, which answer is correct here. Then during storage time, ideally the diode just behave like what, short circuit. Diode behave like what, short circuit. And during the transition time, that now the depletion layer will start increasing. And that's why the current through the diode will start decreasing. That reverse recovery time, when we are saying that reverse recovery time, that is divided into two parts, storage plus transition, then this is the case. In that case, what will be the current? Same current will flow. Then again, when we are making the diode reverse bias, again the current will flow because the diode will act. During storage time, the current will remain constant because diode acts as almost short circuit. And during transition time, if you find any difficulty, then you can ask doubts here. Okay. Okay then. And that is called what? Transition time. In that case, the current will reduce. So what is the concept here? When the diode is forward bias, for example, this is the forward bias and it is forward bias by any voltage Vf, this is R, it will almost act as short circuit, and that's why the current is Vf by R. Vf by R. So this is the forward bias current. At this point, let this is the point t equal to 0, we are making the diode reverse bias by simply changing the polarity of the battery. So when we are changing the polarity, then for storage time, this time is called storage time, it will remain short circuited, almost short circuited. But the direction of the current will change. So what is the direction of the current? Opposite direction. And what will be the current? Almost VR by R. VR by R. So this is the current actually in reverse direction, VR by R during storage time. After that, depletion layer will start increasing. When the depletion layer will start increasing, current will start decreasing. And finally, at this point, this is called transition time. And it will reach to what? Reverse saturation current, that is called I naught. Because in reverse direction, what will be the current? Reverse saturation current I naught, right? Or ideally we can say it will become 0. So this is the case. So this is during storage time. So during storage time, this will act as short circuit. When this will act as short circuit, it is not as the current, it asks what voltage. So what is the polarity of the voltage? Watch this diagram. It will become minus 5 volt. Minus 5 volt. A is the correct answer. Minus 5 volt, because during storage time, initially it is connected to 5 volt, then it is a forward bias. So what is the output voltage? 5 volt. When it is connected to 2, this is the minus 5 volt during storage time. Answer A is the correct one. So please revise all this diagram, guys. What is the reverse recovery time? This is the sum of storage time and what transition time. That is the case. Okay. Okay. No. Okay. This is the time for what? Homework. Please read this question again. That is a very, very important one. It is predicted that for germanium, the reverse saturation current should increase by what? 0.11 degree per centigrade. 0.11 per degree centigrade. Fraction. This is a fraction actually. That is 11%. It is found experimentally in a particular diode that at reverse voltage of 10 volt, the reverse current is 5 microampere. Reverse voltage is given and reverse current is given 5 microampere. And the temperature dependence is only 0.07. So this is called fraction. It is actually a fraction, di naught by I naught. And actually what is the practically, what is measure here? Only 0.7 per degree centigrade. Right. What is the leakage resistance shunting the diode? Diagram not Ashish, which diagram, my dear? Diagram, which diagram? This one. This is the, are you asking about this? Tell me fast. Everyone try to give me the answer for this question. Please take a screenshot, other student. Take a screenshot of this. Last 2 questions. Okay. ये ना, that is on reverse recovery time. Reverse recovery time means initially, just try to understand. First case, always remember this is the diode. Everyone, please focus on the board. Now this diode is forward bias. Diode almost acts as short circuit. So initially, what is the current here? VF by R. This is the current. Now suddenly exactly at t equal to 0, we are making it reverse bias by simply changing the polarity of the battery. Then you can draw the diagram like this. First of all, you can draw the voltage here. For example, this is the voltage. Suddenly the voltage is changed from VF. Exactly at this point it is a forward bias. Suddenly you are changing the voltage at, this is the VR. Okay, this is the voltage. Like now it is a reverse bias after that point. Okay. Then that is about the current, my dear. This is the VF. This is 0. This is, we are changing the voltage exactly at this point. This is the time. Initially what will happen? Now the current is very high. This is called VF by R. When it is forward bias, VF by R, because it will act as short circuit. Suddenly when we are making it reverse bias, so under ideal condition, what we are saying that current will become 0. Yes, Ashish? Suddenly the current will become 0. But practically what will happen, when we are making the diode reverse bias, for a short interval, it will act as what? Short circuit. But the battery, the polarity is reverse. The polarity is reverse. That's why the direction of the current will change. But actually we are measuring the current in this direction. That is the direction from P side to N side, and that we are saying that the current will become negative. Current will become negative. And what is the current? Minus VR by R in opposite direction. For how much time? Already it is reverse bias. For TS time, that is called storage time. So during storage time, the diode will act as what? Short circuit. Then what will happen? Once the minority carrier will reach to what? They will move from N side to P side, and minority carrier will move from P side to what? N side. This is called the during storage time. After that, now the depletion layer will increase. When the depletion layer will increase, what will happen? Now the current will start decreasing, because now the depletion layer will increase. And once the depletion layer start increasing, current will start decreasing through the R. And that is the, so what this is called, this time, after storage time. Constant in a reverse direction. Now current start. At this point, this will become what? Equal to reverse saturation current. And in that case, it is called transition time. This is called storage time. So this point, at this point, we can say the diode is now what? Reverse bias. But we have changed the switch what? At this point. What is the total time taken? TS plus what? TT. Total time is called reverse recovery time. After that, we can say the diode is reverse bias. This total time is called RR, reverse recovery time, TS plus TT. So during TS, almost diode, ideally I am saying that almost diode act as what? Short circuit. Diode act as what? Short circuit. I think now it is clear. यार बहुत बड़ा है टॉपिक, वो 1 घंटे का टॉपिक है स्विचिंग टाइम. नो, व्हाट इज द आंसर एवरीवन? अदर स्टूडेंट्स सॉल्व कर रहा है या नहीं कर रहा है? यार मॉर्निंग सेशन होते ही सब गायब हो गए आप लोग. द बार्क सेशन विल बी एट 11, राइट? रिमेंबर. नाउ टेल मी. This is the 0.07, it is given 0.1, but it is the ideal condition. Again, that watch that ideally matlab means during calculation we are finding that this is the 11% or 0.11, that is the fraction, but practically we are getting the 0.07. So what is the reason here? So what is the reason here? Simply, when theoretically when we are measuring, we are saying that there is a reverse saturation current, and it will flow from P side to N side. And this is called reverse saturation current. And it doubles for every 10 degree rise in temperature. And on the basis of that, we are calculating I naught is equal to what? 0.11 per degree centigrade. But this is the value. This is called what? Theoretical value. Okay. This is the theoretical value. Right. This is the reverse saturation current that passed through the PN junction. But practically what will happen? When we are correcting a reverse bias, there will be the current in this direction, and there will be the some current through the surface. And that is called what? Surface leakage current. Surface leakage current, because on everybody there will be the some charge carriers, right? And because of that there will be the current, and it is ohmic in nature. That is, it will follow the Ohm's law, because there is a charge particle on the surface, and this is called reverse saturation current. But suppose I am connecting one emitter here, it will measure I naught. So what is the I naught actually? Practically I naught is what? I naught dash plus what? IS. So I can say like this is the I naught dash actually. So practically there will be the two current, I naught dash plus IS, but the emitter will measure this I naught, and we are saying that this I naught is what? Reverse saturation current. Second thing, when we are increasing the temperature, new hole electron pair will generated, and that's why this will change. So theoretically this is the value of this current. But practically what will happen? The temperature will affect I naught dash, but it will not affect what? IS. That is the surface leakage current. It is independent of temperature. Now, this will change with the temperature. This will not change with the temperature. Definitely the change in the temperature I naught dash will affect the I naught. In that case, there is no surface leakage current. And that's why the I naught and I naught dash are same. But here, this is the case. To differentiate it with respect to temperature, ये जो है यहाँ पर रखिएगा, यहाँ पर dt भी लिखना होगा because it is with respect to temperature. Correct it. Because it is a fractional change with respect to temperature. It is given di naught by dt, right? This is a fractional change. It is given as 11 per degree centigrade. Or theoretically, this is the I dash. Actually, per degree centigrade. Okay. So this is the value when I am differentiating di naught by dt, di naught dash by dt, because it is constant. That is the case. Okay. So we can say because it is a constant. Second thing, we have I naught is equal to what? I naught dash plus what? Is. So what is the value here given? When we are connecting the 10 volt battery, the reverse current is 5 microampere. I naught dash plus Is, this is nothing but I naught, and that is the reading actually, 5 microampere. Now what is asked here? What is the asked here? The reverse current is 5 microampere and the temperature dependence is only. What is the leakage resistance shunting the diode? When we want to find the leakage resistance shunting the diode, means you have to find the surface leakage current, because the equivalent circuit will become, let this is the diode. We are connecting a 10 volt battery here. There may be some resistance here. We are connecting one emitter here that will measure the value. Now there will be some resistance here. This is called surface leakage current resistance. It will shunting the diode. This current is what? I naught dash. This will measure I naught. This is called surface leakage current, right? Because the value of the resistance is not given, we are assuming that let it is the 10 volt is across the RS. If you find the RS is equal to 10 volt divided by Is. Now you have to find the Is. Is means I naught, it is given I naught dash plus what? Is. You have to find the Is. I naught is given as 5 microampere. I naught dash we have no idea. Is we have to find, means 2 unknowns. So what is the second equation? What is the second equation? Second equation is here, fractional change is given. That is given as actually 0.07. Or normally we are writing like this, na? Normally we are writing like this. Practically, ideally, per degree centigrade. Now, these two already we have proved di naught by dt is equal to di naught dash by dt. How? Because I naught is equal to I naught dash plus what? Is. Because this is a constant, when we are differentiating with respect to temperature, di naught by dt is equal to what? Di naught dash by dt. These two are equal, and that is the value is what? Differentiation with respect to temperature is 0. So these two are same. Please differentiate the equation number 2 divided by 1. When the 2 divided by 1. What will happen? Di naught will cancel out. 2 divided by 1, it will become I naught upon I naught dash. Am I correct? Yes. And this is the 0.11 divided by 0.7, that is become 0.07. It will become 11 by 7. We have to find we have the idea about the I naught. So what is the I naught dash? So I naught dash we can find 7 by 11 I naught. And that is nothing but 7 by 11 into 5. 35 by 11. 35 by 11 microampere. This is the value of I naught dash, ideal reverse saturation current. So this one. Once you will get the I naught dash, from this formula you can find the IS. So what is the IS? Surface leakage current, I naught minus I naught dash. 5 minus 35 by 11. It will become 55 minus 35 by 11. Tell me what is the value? 20 by 11 microampere. Now, if it is known, then what is the surface leakage current? Already I have given the formula RS upon 10 by IS. 10 divided by 20 by 11. It will become 11 by 2. And this is in microampere, it will become mega ohm. 5.5 mega ohm. Because the current is microampere, therefore the resistance will be in mega ohm. So that is it. So formula based question, simple, no need to use the calculator. So 5.5 mega ohm, this is the answer. Are you getting my point? So ideally we are solving number of questions. कैसे? आपको पूछेगा what is the theoretical value? The theoretical value is actually for the germanium is not the 7%. It is what? 11%. It is 11%, but practically it is 7%, and because of that 7% we are saying that it doubles for every 10 degree rise in temperature. When we are calculating 10, it is nearly equal to what? 2. We are saying that the reverse saturation current doubles for every 10 degree centigrade rise in temperature. That is, this is the practical value. Theoretically it increased by what? 11%. Okay then. So this is all about, right, about my session. Please try to solve that. You are on BYJU'S exam prep. My dear friends, please revise what MOS capacitor. You can watch my marathon session on EDC. Already it is before the GATE exam. Quick revision within 2 hours. You can revise all that. MOSFET, special diodes. Please revise the concept of the Fermi level. But remember that you have to give the response as quickly as possible. In GATE, we have time to solve the numericals. But in BARC, you have to maintain the accuracy with what? Time management. बहुत ज़्यादा टाइम मत लगाइएगा. अगर कोई क्वेश्चन आपको परेशान कर रहा है, बहुत ज़्यादा कैलकुलेशन है, प्लीज ड्रॉप दैट क्वेश्चन. ओके, बाद में बनाना लास्ट में जब हो जाए सॉल्व. तो यू आर ऑन BYJU'S एग्जाम प्रेप. थैंक यू फॉर अटेंडिंग द सेशन. थैंक यू वेरी मच एंड गुड लक फॉर ऑल कमिंग एग्जाम्स. और अब तो होली भी आने वाली है, तो हैप्पी होली गाइज. मे गॉड फुलफिल ऑल योर ड्रीम्स. थैंक यू. Happy Holi.